Hello guys, this is Prime Concept. In this video, we want to further our explanation and location of images or image position on a concave mirror. In the previous video, we looked at two separate positions. We mentioned when an object is at a very far point at infinity, where will the image be formed, right? So we were able to discover that the image will be formed at the focal point. The second one we considered in the previous video was if the object is behind the center of curvature, where will the image be formed? And we found out that the image will be formed between the center of curvature and the focal point. In this video, we want to look at the third position. Number 3. When object is at C. That is to say, when your object is at the center of curvature, where will the image be formed? If you have been following me, if you have been watching my videos and you followed till this point, please do well to hit the subscribe button. Always like when you see my videos, comment, and then share with your friends so that they can also benefit. If you have been watching me from Nigeria, any of the Nigerian university, I really appreciate you for consistently following me and growing my page. I really appreciate you. If you've been watching me from any part of Africa, Ghana, and any other country, I really appreciate you. Do well to keep watching, sharing with your friends. If you've been watching me from US, the UK, Canada, I see your comments. India, I really appreciate you. Thanks for supporting me. Do well to keep following me. Thank you. Now let's analyze this. So this is our concave mirror because that is what we are still looking at. Now I have my principal axis. This is my focal point. This is my center of curvature. Remember, we're trying to look at when the object is placed at the center of curvature. And I told you we denote object with straight lines pointing up. So this is my object, right? And when you are drawing your ray diagrams or when you're drawing your rays, they should always come from the tip of the object. So I'll use one of the rules, which says if I have a parallel line, I have a ray parallel to my principal axis. When it hits my mirror, it will reflect passing through my focal point. So if I do this, I would have this. I need another rule to complete this. Now I'll be using the rule when your ray passes through your focal point, it will reflect parallel to the principal axis. So I'm going to do this. So this is my ray passing through my focal point. So when it reflects, it will come this way. So it will come this way, even though my diagram is not very much to scale. So this is what I have. Because if you use your scale diagram, you would see you will get the exact thing, right? Very accurate, very perfect. Now this is my reflected ray. Now your image is located where your reflected rays intersect. So this is one reflected ray, this is another, and you can see where they intersect, right? So if I try to draw this, you will see that the image is formed at this point. So let's list the properties of the image formed from this. I believe you can even point them out yourself by watching this. So let's list them. Properties. Number 1, the image is located at C. The image is located at C, at the center of curvature, right? Number 2 property is that the image is inverted. So you can see our image facing down. This is my image, this is my object. So you can see my image facing down. So it means my image is inverted. Number 3 property, of course, if you have an inverted image, you expect that image to be what? Real, right? And why is it real? Because it's in front of the mirror. So image is real. Number 4 property, you can see that the image is exactly the same distance from your mirror as the object. That is to say, the distance from here to where your image is the same distance from here to where your object is. So it means that image is at same distance from mirror as object. So that is to say, in short, the image distance v is equal to the object distance, right? Now, if your image distance, let's say, is 15 centimeter, what do you think your object distance would be? You are very correct. It would be 15 centimeter also. Now, you would notice that it is only under this condition for a concave mirror that you can obtain a magnification. It is only under this condition for a concave mirror that you can obtain a magnification of 1, of unity, right? Now, why would you get a magnification of 1? If you recall, you will notice that magnification is the ratio of image distance to object distance. So if the image and object distance are equal, automatically you expect your magnification to be what? 1. So it's under this condition that you get a magnification of unity, which, if you notice, this is very much similar to your plane mirror. So you still know that it is under this condition that your concave mirror can somewhat behave as a plane mirror, right? Now, we still have a fifth property we want to also add. Number 5 is that the size or height of your image is the same as the size or height of your object. The size / height of image equals that of object. I don't have space. So the size or the height of your image equals the size or height of your object. So these are properties you should note from this, and that is why your magnification is 1. I believe this concept is very clear. In the next video, I will look at when the object is placed in front of C. That is to say, when your object is between C and F, where will the image be formed? And in the next video, I will give you the secret behind these things, right? Tell you how this image, the object, moves and how the images also move. Thanks for watching. If you have watched up till this point, please do well to subscribe to my channel, like, comment, and share with your friends so that they can also benefit. Remember, this is Prime Concept. Thank you.